Hey guys, welcome back. We're doing Overthewire Bandit. We've already solved 10 levels. Now we are going to look into level 11. The password for the next level is stored in a file called data.txt, where the lowercase az's and uppercase az letters have been rotated 13 positions. So this is basically rot 13 rotation. As always, let's do SSHER and Bandit 11. It's connected. So let's see, there is data.txt file. So the letters are basically rotated. So typically one thing that you can do is you can use tr for this to transform, or you can find a rot13 decoder online. I also wanted to show you guys a little bit of perspective, right? So let's actually see how we can also leverage aliases to perform such kind of acts, because if you wanted to do this on a routine, that could come in handy. So first let's take a look into what tr does. So let's do tr is to transform. So for example, let's say if I wanted to transform all the spaces into new lines, right? I would mention space and I would say /n for new line. So essentially what happens is all this space is changed into new line, right? I can also change that to a comma, so it becomes a comma, so on and so forth. Now what we're going to try and do is we're going to say, can I change a letter? Like let's say change all the G's to 9. So it's going to change the G's to 9, maybe change all the G's to space. You can see now it's changing them to spaces, right? So we can mention something like change everything that is between A to Z and A to Z to what is the 13th letter? 13th letter is N. Let's do N to Z and sorry, N to A and N to small n to um, small a. I think that's how it should work technically. Let's do A to Z and A to Z, N to A. Hopefully it works. Let's see what we get. It says NA is reverse relating. Okay, N to Z, and let's do MN to ZA, and that to M again. Uh, that's creating a mess. All right, so what are we doing wrong? N to Z, and then let's do A to M, sorry, and then N to Z, A to M. Okay, so does this work? Okay, this is work. So I missed hyphen there. So essentially what we're trying to do, trying to tell tr is trying to tell change all the A to Z's to N to Z and A to M, N to Z and A to M. So N to Z is like the second 13 letters, A to M is the first 13 letters, so on and so forth. So that is working. Now what we can do is, if you are doing this kind of, if you play CTF like on a regular basis, you can set an alias, right? So let's do something like what I'm using, which is, I think I'm using ZSH, right? Okay, so let's actually go ahead and edit the ZSHRC file, and we'll find something called alias. Okay, so what we'll do is we'll mention a new alias. Okay, maybe somewhere on the top. There's a very colorful stuff. Anyway, let's call it aliases, something like that, and let's do alias, and we can give it a name. Let's do something like rot13, and mention that. I think we just have to change the quotations. Let's change single quotes, right? Hopefully this works. So that is the new alias. Let's reload SSH. Maybe let's exit and then split again. So SSH reloads. Rot 13. Alright, so rot 13, and let's given the string, paste the string. Uh, what happened? Okay, so what we have to do is, I'm sorry, I thought it was taking input. However, we just set up the alias, right? So let's do something like this. What happened? Okay, so let's check the alias again. Alias tr a to z, a to z, n to z, a to m, n to z, a to m. That seems fine with me. What exactly is the problem? When we pipe it to rot 13, doesn't work, right? Oh, okay, I'm changing the correct one. So let's actually change this, right? My bad. Let's echo that to rot 13, which is our alias. It should work. Doesn't it's throwing us a okay. Maybe there is an issue with the quotations. Tr z do all right. That should technically work. Okay. So it is changing to okay, again I'm feeding the wrong data. Sorry about that. Okay, let's copy this. Now that we have rot 13 configured as alias, let's do rot 13. Okay, now that works. So you can configure aliases in such way so that it's going to help you make your job easier. Let's exit out of this for now. So now we have solved this level. So let's copy that. Um, let's exit out of this. Let's configure the new one for the next level, right? All right, so Bandit 12, we got all the credentials. All right, so let's go ahead and yank that. Let's create a new one for Bandit 13. We'll update the password once we solve that level. All right, so let's save it. Okay, so SSHER, let's do Bandit 12. Should work. We logged into Bandit 12. Let's see what we have to do for Bandit 12. The password of the next level is stored in data.txt, which is hex dump of a file that has been repeatedly compressed. So it's basically a hex dump that is repeatedly compressed. All right, so we need to make a new directory in temp and work there. So let's go ahead and see how we can do that. So let's read the data.txt file. So this is the hexadecimal dump, or called hex dump. If I run a file command on data.txt, it says it's ASCII text. Okay, so let's to work. Let's do make directory, and let's create a new directory on temp. Let's call it please sub. Okay, so we made a directory. Let's copy this data.txt to temp please sub. Okay, let's move to temp. All right, so we moved into this directory. Let's verify the integrity of the file. Let's do md5 sum data.txt and md5 sum of the original file, which is home bandit 12, I guess, and data.txt. So it is the same md5 signature, so it is the same file, it's not tampered. So let's work on this file. So let's do take data.txt, cat data.txt, and what we'll do is we'll use xxd. Xxd is a tool that can read hexadecimal, values. So man xxd, make a hex dump or do reverse. So it's either used to make a hexadecimal dump, or you can do the reverse. So you can use the -r flag to retrieve, reverse the stuff. So let's do cat data.txt xxd-r to reverse it. If this is the data that we get, we know that it is a compressed file, right? So let's go ahead and save that to one. Let's just call it one to have a count of it. So one, let's run a file command on file one. Okay, this one says gzip compressed data was data2.bin. So let's actually rename it to a .bin file. So move one to one.bin. All right. Okay, it says gzip compressed, so it should be .gz. Okay, let's move one.bin bin to one.gz. All right. So gz is basically gzip. Gunzip is a command used to extract stuff that is, that ends with gz. You can also use tar-tr to extract it, right? Let's extract it. Now we are getting another file called one. Okay, so let's do file on one. It says it is bzip2, right? Let's move one to 2.bzip2 extension. So now we have a new file called 2.bzip2 extension. But bunzip, I think bunzip2. Let's do man bunzip2. Okay, bunzip2 is a program used to decompress the bzip files. So let's go ahead and do bunzip2 2.bzip2. We have 2.bzip out. Let's run a file command on that. So this says it is gzip again. Let's move the file to 3.gz. So now we have 3.gz here. Let's do gunzip or gunzip 3.gz. So we have the extracted file, which is 3. Let's do file on that. It's a tar archive. So let's move 3 to 4.tar.gz. So we have the tar.gz file. Let's do tar-xzf. Xf should be enough. Anyway, let's do it on that file. What is the problem? tar-xf. Okay, tar-xf. So now we have data5.bin. Let's actually remove the fourth one. We have data5.bin, right? Let's run it on file command on data5.bin. It says tar archive again. Let's move data5.bin to 5.tar.gz. Now let's go ahead and do tar.xf 5 tar, sorry, it should be xf, and we have data 6.ben. So let's remove the fifth one. Let's run a file command on the VM is a bit sluggish, so that's why having issues with the typos. Now this is a bzip2 file, so let's move data 6.bin to 6.bzip2. So we have the 6.bzip2 file, bunzip2 6.bzip2. All right, 6.bzip2 is out. Now let's run a file command on that. So that is a tar archive. Let's move 6 to 7.tar.gz. Now let's go ahead and unbundle that tar-xf 7. Now we have data 8.bin. Let's remove the seventh one. Let's run a file command on data 8.bin. So we have gzip compressed data. So let's move data 8.bin to 9 dot 8 8.gzip or gz, I guess. Right, 8.gzip to 8.gz. All right, so let's do gunzip 8.gz. So we have 8. Let's run file command on 8. It says ASCII text. Let's try reading that, and that says the password is this. So we just have to, extract or decompress or unbundle the files multiple times to get the output. Anyway, we got the password. This level is done. So let's go ahead and modify our configuration. So let's go ahead, update the password for, oh man, update the password for level 13. And let's also go ahead and yank that, create one for the next level, which is level 14. Let's do 14. Now let's do SSHER to level 13. It should possibly connect. Okay, it connects. Let's see how we move from level 13 to 14. The password of the next file is stored in etc bandit pass slash bandit 14, can only be read by bandit 14 user. For this level, you don't get the next password, but you get a private SSH key that can be used to log in. Note localhost is the host name that refers to the machine. All right, so it can be read by the user bandit 14. So let's go ahead and see how we can do it. So it is a SSH private key. Let's read the SSH private key. Okay, this is the SSH private key. So we probably have to use this SSH private key to log in. So let's do SSH dash I guess. So if I do SSH dash H, dash I is to given the identity file, which is nothing but the private key. Let's do SSH dash I and given the identity file, or in this case SSH private key, and we are logging in as the user bandit 14 at localhost. You can either mention localhost or 127.0.0.1. It's all the same, right? Are you sure? Yes, I'm sure. Yes, and we logged into bandit 14. So now what do we do? So this level is over. How do we move from bandit 14 to 15? All right, so the password is also this, right? The password for the next level is stored in etc bandit pass Bandit 14. Let's read that because we would need the password. Okay, let's copy that. I'll put it somewhere here for now. So let's go to bandit 14 to 15, see how we can solve that. The password of the next level can be retrieved by submitting the password of the current to port number 30,000 on localhost. So how do you submit a password to port number 30,000 on localhost? You can do it in multiple ways. Netcat in one way, telnet is another way. So let's see telnet. Telnet localhost 30,000. Localhost 30,000. Let's copy the password for the current level and paste it. Enter. Okay, correct. So we get a response which is the password for possibly the next level, which is 15. So let's go ahead and exit. And what we'll do is, okay, exit again. Let's do save the password for level. Okay, level 14. I don't know if it's going to log in for us. Anyway, this is for level 15. Level 14 password. We'll copy that and let's go ahead, delete that there and paste in the level 14 password. Now, all right, I need to yank that. Let's put in a comma and let's paste in, and let's delete this, delete that. All right, let's yank that. Let's go ahead and paste that. All right, so let's actually delete what we have here and then paste that. All right, I think I yanked the wrong one. So anyway, let's go back in the VI mode, yank that. Let's go back, paste that, and close it. And let's remove this. All right, now that is bandit 15. Let's see if we can log into bandit 15. Hopefully we didn't make any errors. All right, so we logged into bandit 15. Let's see how we solve bandit 15 to 16. Let's list out what is there. Nothing. The password for the next level can be retrieved by submitting the password for the current level to port number 30,001 on localhost using SSL encryption. Hopeful note: getting heart beating and read R block. Use dash IGN underscore EOF. Read the connected commands section in man page. All right. So we have to submit an encrypted stuff. So possibly we have to use OpenSSL, S-client, and stuff like that. So let's do man OpenSSL. All right. OpenSSL is a cryptographic tool, and example. Let's see. There are a lot of examples available. Okay, these are all the ciphers. Okay, let's also do man S client. This is OpenSSL S client. The S client commands implements a generic SSL client which connects to a remote host using SSL TLS. It's very useful diagnostics tool. All right, so you probably have to use this, which is S client. And what do we do? Current level port number 30,000. All right. We have to use probably the dash pass argument. The private key password source for more information. All right. So S client. Uh, okay. Not found. Maybe we have to use in combination with OpenSSL. All right, so let's see if we can use this in conjunction with OpenSSL. OpenSSL is client. Okay, that is working. Man is client. How do we connect? Dash reconnect, dash connect, host and port. So we have to give in the host and port using a dash connect flag. So let's do dash connect, and the host would be localhost, and the port would be 30,001, and then it says extended master secret. All right, so we have to submit the password for the current level. I mean, the password for the current level is in Etsy Bandit pass Bandit 15. So let's actually copy that, and let's do OpenSSL again. Paste in the password. It says correct. All right, so we got that done. Let's exit. Let's go ahead and do vim. All right, so we just have to yank that and save it for the level 16. Put a comma, paste that, change this to level 16, change level 16 again. Let's yank that. Let's go ahead and paste that. Let's remove this, and let's correct the quotations. Hopefully we should be able to log into Bandit 16. Let's verify that. And yes, we are able to log into level 16. So thank you so much for watching, guys. Level 16 to 20, we'll take a look into another video. A subscribe would be nice.